David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Okay, today's lesson, we're going to talk about significant digits and rounding. And before we jump into that, I just want to stress this is something you're going to need to know for almost every IB test question that you answer. And these two items are worth 1 point on every test. So if you do it 10 times, you get it 10 times right, you get that point. If you miss it on any one or all of them, you'll lose that point. So I will do my best to grade you accordingly so you learn what that's about. So let's get into this. First off, significant digits. This causes people some grief, and in science and in math it's an important concept. There are 3 basic rules to determine significant digits, so let's go over those. First off, I want to talk about a couple terms. Decimal places. This is the number of digits after a decimal point. So if you write the number like 4.6704, there's 4 decimal places in that number. Okay, second one is significant figures, and here are these rules that I talked about, or I mentioned. So any non-zero number is significant. So if you see a 5 in there, or a 7 in there, or a 2, each one of those is a significant digit. Zeros are where it's tricky, so the next 2 rules deal with the zeros. Zeros between any 2 non-zero digits are significant. So for example, if I write the number 4007, the digits, any non-zero digit is significant, so I have 2 of those, and then I have 2 zeros in between my 4 and my 7. So this one has actually 4 significant digits, okay? Now the next one is a little different, and it's also tricky. Trailing zeros are significant if they come after the decimal point. So for example, if I do 4.50, that has 3 significant digits because I've got a 4.5, so the 4 and 5 are non-zero digits, and then the 0 is coming after the decimal. It's on the right side of the decimal point. If I write the number 450, that only has 2 significant digits because this 0 is not to the right of the decimal, so it does not count as significant. So the zeros are a little bit more tricky, but I think with practice you can get there. Oh, yeah, and of course, speaking of practice, let's do some right now. So I've written a bunch of numbers here, and let's go through those and figure out how many significant digits there are for each of these numbers. If you're feeling adventurous, what I'd like you to do now is pause the video and see if you could apply all 3 of these rules and come up with the correct number of significant digits for each of them. So I'll kind of pause for a minute there while you do that. Okay, so hopefully you went through and you wrote those down. Now let's see how well you did. This first one is pretty easy. I have 3 digits, they're all non-zero, so I've got 3 significant digits. Second one, I have 4 digits and the 0 is in between 2 non-zero. So this one has 4. Now this one is a little bit more tricky. Everything is to the right of the decimal, so I have a 5 and I have a 0. This 0 is to the right of the decimal, so that counts. I have a 5 and a 0, that's 2. Now this 0 doesn't count. It's not covered under this rule because it's to the left of the decimal, and it's not sandwiched in between 2 non-zero numbers. So this one only has 2. I know, kind of tricky, but as you practice this, it's going to get easier, I promise you. Okay, how about this one? What do you think? This one has 4. I have 2 zeros that are in between the non-zero numbers, so that's 1, 2, 3, 4. This is a trailing 0. There's no rule about a trailing 0 when it's not to the right of the decimal, so that one's 4. How about 600? That's 1. The zeros don't count. Neither of these rules cover these 2 zeros, so we just have 1 significant digit. How about this one? That's 3. These are leading zeros. They are to the right of the decimal, but they're not trailing, they're leading. These are trailing zeros, so I have a 3 and these two zeros. And as you know from this one, this problem up here, this leading zero doesn't count. So this one has 3 digits. How about that one? Did you say 4? Because if you did, you're right. This one has 3 non-zero numbers, digits, and then 1 trailing zero that's to the right of the decimal. So that's got 4 digits. And lastly, how about this one? 3. This is a leading zero. It is to the right, but it's a leading zero. So like these two, it doesn't count. And then I have a digit that's in between the 3 and the 4, so that zero counts for that reason, and that gives us 3 digits for that one. Okay, now let's add rounding to the mix, because you're going to need to round in IB math questions, and you'll be requested ultimately to round to a certain number of significant digits. But first, let's do a quick review of just basic rounding, just to make sure we're on the same page. So rounding, let's do a couple of the typical types of questions you might get. Here's a number that we're going to round. Round 4,289 to the nearest 100. So the nearest 100 is right there, the 289. So one trick you can do, don't have to, but it might help. I'm going to round to that 100. Now what I do is I look to the next number. Is that number bigger than 5? If it is, I bump the 2 up and I put zeros here. So this one would round to 4,300. And the way to think about that is the nearest 100 is, well, it's at 200, but this thing is pretty close to bumping this up to 3. So 289 is closer to 300 than it is to 200. So that's why the result gives us 4,300. Okay, so let's do another one of those. You might pause the video and see if you can do this first. Check this out, 13,452 to the nearest 1,000. So now we're going to be looking towards the thousands place. We look to the next number. Is it bigger than 5? No, it's not. So we're going to not bump the 3 up and add zeros there. So this one's just going to be 13,000. And a way to think about that is that 13,452 is actually closer to 13,000 than 14,000. So in this case, we're going to round down. This one, we rounded up. Okay, so that's your basic rounding. And if you struggle with that, let me know. I can work with you. There's tons of tools online to help with rounding. I'm sure there's some automatic rounding calculators on the web that you could, use to explore and play around with. Okay, now let's add rounding to significant digits. Okay, and first off, I want to tell you that writing out significant digits is kind of long, so sig digs is perfectly fine. If you use that vocab in class, I'll know what you're talking about. Okay, so here's the type of a question you might get. Round this number, 0.1235, to 2 significant digits. So they're not saying to the 10,000th place or the hundredths place. They're just saying your answer needs to have 2 significant digits and it needs to be rounded to there correctly. So here's where that underlining trick works. Here's 2 significant digits for this type of number, right? If I reported all of those, that would be 4. So I can only report to the hundredths place in this number, and so I'm going to look to the next one after the 2, and that's a 3. So we're not going to round the 2 up, so this one's going to be 0.12. And the way to think about that is that this number is closer to 0.12 than it is to 0.13, because the 3.5 afterwards isn't big enough to bump us up. Okay, so let's do 3 more. If you want to pause the video right now and give these a try, and then see how you did, that's fine. Okay, so here's our number, another 4-digit decimal, 0.2965, and we're asking to round this one to 2 significant digits. Now this is going to go a little different, because here's where we have 2 significant digits, but we look to the next one. Now that's a 6, so that certainly is 5 or bigger, so we're going to use that 6 to bump the 29 up. But that goes to 0, right? So what happens when this goes to 0? This goes to 3. So our answer here is 0.30. We need to keep that last 0 to have 2 significant digits, okay? Let's try this one. 415.25 to 3 significant digits. Now I happen to have 3 right there. I don't need a decimal. In fact, I can't have a decimal in this result if I'm only using 3 significant digits. So I'm going to look to the next one. That's a 2, so that's not going to increase the 5 to a 6. So I'm just going to write 415. And I'm not going to write 0.0 because that would be 4 significant digits, and it only wants 3. Okay, this last one, round 3050 to 2 significant digits. So that's going to be right there. I'm going to have 2 digits there. I look to my next one. That's a 5, so that bumps the 0 to a 1, and I get 3100. And that's 2 significant digits. Remember, your trailing zeros don't count if they're not to the right of a decimal point. Okay? Okay, so let's bring this stuff home in a calculation problem. This is a pretty common kind of an instruction you'll get with the IB. We've got rounding, significant digits, and calculations. So let's do one. This is a pretty straightforward calculation. Here's the type of instruction you might see. Calculate the following to 3 significant digits. Okay? So what you're going to do is you're going to pull out your calculator and you're going to key this in such a way that you don't round it early. You want to leave all the values in your calculation, and then when that spits out, you're going to get something like this, 1.622222695. Now that's what I get when I do the calculation without rounding along the way. So with the IB calculator, it's pretty easy to do that. You can just type it all in, it'll show you everything in there, and then you hit equals at the end, and that will give you this big long decimal. However, our instruction says to 3 significant digits. So we've got 1, 2, 3. There are our digits, and guess what? That 2 is not going to move that 2 up. So this is going to be rounded to 1.62, just like that. Okay, one last type of calculation, and we're going to bury this a little bit more into sort of a word problem kind of thing. So check this out. A circle has a radius of 12.4 centimeters. So here's one way you might be asked to do something with that information. Calculate the area to 4 significant digits. So what we're going to do is we're going to use the area formula for a circle. Area equals pi r squared, which is going to be pi times 12.4 squared. So I'm going to get out my calculator and just do that. 12.4, square that, and then multiply it by pi. And there's a pi button on your calculator. Don't type in 3.14, use the pi button, because then you'll get the correct number of digits. And so what I get here is 483.05128. And I got a few more decimals. I'm going to stop there because I already know I only need 4 sig figs. So here it is, 1, 2, 3, 4. So I look to the next one, and that is a 5 or bigger. So this is going to round to 483.1. So that's a correct treatment of that instruction. Okay? Now let's do another circle calculation with the same data, but this time we're going to do circumference. But check this one out. Now they're saying to 1 dp, and you'll see that in the book. It means decimal point, okay? They like their abbreviations in the IB. So now we're going to do circumference equals 2 pi r, which is going to be 2 times pi times our 12.4. So I'll put that in my calculator. 2 times pi times 12.4, and I get 77.91149,781. Okay, so check this out. I've got to round this to 1 decimal point. Okay, so that's going to be right to there. So I look to the next one, and that's a 1. So that's not going to change that 9. So we're going to end up having 77.9 centimeters m. This is centimeters squared. So there you go. Now let me summarize this. A lot of times people will write answers on tests like with that many decimal points. And it takes time, and you don't need to spend that time. In the IB, you're actually going to miss a point on the test if you do that. So these instructions are actually going to be very clearly your guide to exactly how to round your answers for IB test questions. If you don't have an instruction, if it doesn't say, then the assumption is 3 significant digits. That's how you want your answer. So for example, let's say you did a calculation and your answer was 4,879,225, and there was no instruction. 3 significant digits is right there. So your answer would be 4,870,000. Now that 2 is not big enough to change the 7, so you make it a 0. And so that number is this one rounded to 3 significant digits. Okay? Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.